Hello everyone, welcome to the Mathematics of my channel. Today here we have 0 to 5 over 2 natural log of sine of x dx. As I remember, we solved this integral in a few years ago. Anyway, before 3-4 years, when I taught to grade 12 class integration, um, I remember this one is very hard for grade 12 integration students. 0 to 5 over 2 natural log of sine of x dx. But we can teach this one very clearly. So this is the way how I teach this integral for grade 12 students. Okay, first we have 0 to 5 over 2 natural log of sine of x definite integral. So first of all, we know about this formula, integral from 0 to a f of x dx is equal to integral from 0 to a f of a minus x dx. Here f of x, here upper limit a, so here a minus x. So we are going to apply this formula to our integral. At the same time, I'm going to take our integral is equal to I. Then if we apply that formula, we have 0 to 5 over 2 natural log of sine of 5 over 2 minus x. Here 5 over 2 because here upper limit 5 over 2, and here we have dx. Okay, then we know about trigonometry. So natural log of sine of 5 over 2 minus x. We know sine of 5 over 2 minus x, first quadrant. So natural log of cosine of x dx. Okay, now here we have I. So we convert this integral into this integral. So this one also we know equal to I. Then we are going to take the sum of these two integrals. So I plus I, we know 2 times I is equal to, now we have 0 to 5 over 2 natural log of sine of x dx plus second integral 0 to 5 over 2 natural log of cosine of x dx. Okay, now here same boundaries. So we can write these two integrals into one integral. So we have same boundaries. So 0 to 5 over 2. Here we have natural log of sine of x plus natural log of cosine of x, and here dx. Okay, then we know about natural log. So if we have natural log of a plus natural log of b, we know this one is equal to natural log of ab. Therefore we can write here 0 to 5 over 2. Here this one looks like natural log of a plus natural log of b. So we have natural log of ab. ab means here sine of x cosine of x dx. Well, then here we have sine of x cosine of x, little bit familiar with us. We know about double angle formula of trigonometry. Sine of 2 times x is equal to 2 times sine of x cosine of x. Then if we isolate the sine of x times cosine of x, we have sine of 2 times x over 2. So now our integral becomes 0 to 5 over 2 natural log of, now we know this one, sine of 2x over 2 dx, because sine of x cosine of x is equal to this part. Well, then again natural log. If we have natural log of a over b, we know natural log of a minus natural log of b. Well, then Let's see next step. So 0 to pi over 2. Now we know here natural log of sine of 2 times x minus natural log of 2 and here dx, because we know about this one. Okay, now here we have 0 to 5 over 2 and here minus, so minus or plus whatever. We can separate this integral like here natural log of sine of 2x, then here dx minus 0 to 5 over 2 natural log of 2 dx. Okay, then for this integral I am going to take a substitution. 2x is equal to t. Here we have 2x. So if we differentiate, 2 times dx is equal to dt. So we can write here 0 to now we should change the boundaries. Here pi over 2. So we know when x approaches to 0, t approaches to also 0. When x approaches to upper limit pi over 2, t approaches to here 2 times pi over 2. So we know pi. So we have 0 to pi, 0 to pi, natural log of sine of sine of here 2 times x. So now we know 2 times x is equal to t. So sine of t. Then dx, if you isolate the dx here, dt over 2. So here dt over 2. So 1/2 is a constant. So we can write constant outside of the integral sign. So 1/2 natural log of sine of t dt minus, now here natural log of 2 is a constant. So we can write again outside of the integral sign, and here 0 to pi over 2 dx. Well, then here 1/2 integral from 0 to pi natural log of sine of t. In the beginning we discussed about definite integral formula. Here this one also we know it looks like here 0 to a f of x dx is equal to 0 to a f of t dt. This one we know definite integral independent of the variable, here x, here t. So different variables but the same boundaries. Okay, then we can write here our integral natural log of sine of x dx, then here minus. Now if we integrate here we know x, so natural log of 2 times x from 0 to pi over 2. Okay, then here 1/2. Then again we have another formula, 0 to 2 times a f of x dx is equal to 2 times 0 to a f of x dx. 1/2. Now we are going to apply this one. So we have 2 times upper limit we know here 2 times a, here a, so pi over 2 natural log of sine of x dx minus, here if we apply limit we have pi over 2, so pi over 2 natural log of 2. Okay, then we know this 1/2 2 get cancelled. Now are you happy? I am happy because we know this one our integral 0 to 5 over 2 natural log of sine of x dx. So this one also equal to I. So we know here 2 times I. So we have now 2 times I minus I is equal to minus 5 over 2 natural log of 2. Okay, 2 times I minus I, we know I is equal to minus pi over 2 natural log of 2. Okay, this is the answer, and that's the way how I taught to my grade 12 students. Okay, thank you for watching.